Math is abstract. Okay, and I'm going to try to make it simple for you. I hope that I can I can succeed in that effort. Okay, so function is one of those abstract concept, but it's a very powerful concept. Okay, so first of all, let's read this function. It says a function is a rule. Okay, a function is a rule. A function is a rule. Do you guys see that? A function is a rule. And then there's a description about this rule. Do you guys follow me? Okay. There's a description about this rule. Okay. This rule will assign each element in the set of A. Okay. So the common picture you see is that you have a set of A. This is A. Okay. And there's an element in A. Okay. We assign values in A. Okay. And we call this element X. So for this element, okay, and we're going to have an assignment to it. So all the assignment will get to another set called B. And this rule we call F will do that work. Okay, so how does it do it? Okay, we'll take this rule, so this rule is F. So this rule will be applied to this element in A, and the consequence, it will be in the element of B. Okay, it will be an element in B. But in this function definition, it says for each element in A, it assigns exactly one element called f of x in B. So this element here is f of x. Okay, so this assignment by the function, and we have to guarantee there's exactly one element. What does it mean exactly one? Could you guys tell me, what does it mean exactly one? What's the meaning of exactly one? What's the meaning of exactly one? What is the meaning of exactly one? Everybody? I wish you to hear some answers. What does it mean exactly one?
That is just one.
One and only one, right? Exactly one certainly is different from one, right? Exactly one is meaning that you have one, you cannot have less than one certainly, but you cannot have more than one either. So exactly one means unique. So exactly one means unique. Unique. Do you agree?
Yes.
Okay. So that's what exactly one means. Okay. That's exactly one. Now, for each element X in the set of A. So you may have many elements. Every element will have exactly one. Every element will have exactly one. For example, you have another heart. Okay, say heart number 2. Heart number 2. Heart number 2 will also have assignment. It gets to the other set following the same rule. And that will be exactly 1 as well. But in this sentence, it didn't say these 2 have to be different. Okay, as long as you have 1 here, for each element in A, you have exactly 1 in B, then we're fine. We're fine. Okay, do you guys follow me? Now, this is the function of definition. I tend to use another setting of notation, another set of notation. Okay, this is the set of notation I meant. Okay, this set of notation I use is often like this. The element in A, I will call it input. The input is given to this rule or a machine. Okay, you can view it as a machine. And this machine is called a function. So this function takes the input f of x, it produces an output, and this output is f of x. Okay, sometimes some book call it y. You can do that too. But this letter notation, you will see over time, is preferred because this notation tells you the input, it tells you the output at the same time. So this notation basically says, okay, for input x, the output is f of x. Okay, or the output is f of x for input x. So that's what this notation means. The reason the letter notation is preferred because it tells you the input output at the same time, and also there's a description of the rule. Also, there's a description of the rule. Okay, now let's look at the first function. The first function is f of x equals c. I'm gonna erase all of these. Okay, do you guys understand this notation? Input x, output f of x. Okay, I want you guys to gradually transition to use f of x. Okay, f of x. So this is the input. Okay, so the function is a rule. This rule applies the input, it produces an output. So what does this mean? So what does the first example means? First example says f of x is a constant. C represents a constant. Okay, C is the first letter of constant. It could be any number that's given. Okay, it can be any number. It can be any number given. For example, I can give you a function f of x that the constant is a 2. And what does it mean? It means that you have input. Okay, your input is x. The output is going to be 2. The output is 2. The output is 2. You give me input anything, I will produce the output too. That's what it means. Okay, the output is 2 for any input X. That's the meaning. Do you guys follow me? Do you guys follow me? Hello, is everybody here?
Yes.
Yes.
That's what the rule means. Now, how about what is A, what is B then? Right, because in the definition of function, there's something we mentioned A, there's something we call B, right? And we know that A is a collection of input and B is a collection of output, okay? So A is a collection of input and B is a collection of output. Okay, but in mathematics, we're most interested in all the possible input. Okay, because once a rule is set, once a rule is determined, and we want to know this rule can apply to what numbers, and we want to have the collection of all of those numbers for which the rule can apply. Okay, so what is wanted is all the possible numbers that the rule of the function, could apply. If we can find all possible numbers that this rule can apply, and we will call it a very special name, we call it domain. Do you follow me? Does everybody follow me?
Yeah.
So collection of input. So once we have a rule, think about it. Once you have this rule, and this rule will assign each input exactly one output. And we want to know this rule can apply to all of those possible numbers. And we're going to put them together. We're going to call it domain. And the other wanted will be the range. Okay. And what is the range? Range is all possible output. Okay. All possible output. All the possible outputs. So you can see we have a rule. We want to know where this rule applies. And the range tells us what are the consequences. So the range is a consequential. It's a consequence of applying the rule to all possible inputs. And the consequence is the range. All the consequence, the collection of consequential values, they are range. So you guys have probably heard about domain and you have heard about range, right? Now, input output. For this particular function, f of x equals to 2, can you tell me what will be the domain? In other words, can this rule apply to what numbers? What can this rule right here, this rule apply to? And for each one of those numbers we apply to, will produce exactly one output. You follow me? What are all those possible numbers? What do you think? What do you think? Hello? Let me see the chat. 6. What is this answer for Marcello? What is 6 for? Marcelo, what is 6 for? Hmm? Plug in for X.
Oh, isn't it 2?
The domain?
Yes, the domain, isn't it 2?
Domain is 2? I think the rule apply to a number, the output is 2. Okay, so let me explain this a little bit more. Okay, according to this rule, suppose you give me the input X equals to 3, and the output is going to be 2. Input 3, the output for 3 is 2. If you give me input 0, the output for 0, for input 0 is going to be 2 as well. So no matter, according to this rule, no matter what you give me, the output is going to be 2. The domain is what? What number can this rule apply to? Plug in for X. Right, you give me a value for X, the output is going to be 2. For example, yeah, it is plug in. Okay, so if I give you, say, f of 10,000, that's the input. The output is what? The output is 2, according to this rule. So what can all these possible input be? Would that be all real numbers? Would that be all real numbers? Do you guys follow me?
Yeah.
So the domain is what? Is all real numbers. Right? The domain is not true. Domain is all real numbers because you can apply any, you can plug in any number. Okay, see, I'm going to plug in a negative 100 and the output is what? Its output is 2. So any number can, this rule can apply to any number because they're going to produce the same output. And for each of those numbers, the output is unique. For each number, the output is unique. For each number, the output is unique. Even though the output are the same, but for each input, the output is unique. Starting to make sense. Very good. Thank you for your feedback. Does it follow me? Do you follow me? So now what is a range? Range is a collection of numbers after the rule applies to all the possible input. So you imagine you have this bunch of input here. You have a bucket of this input. And you apply the same rule to each element in the bucket. And you get a consequence. And what are all the possible consequences? So what do we have here? What do we have here? What do we have here? There's only one number in the range, isn't it? So that range is what? We use a curly bracket, 2. There's only one output. For each input, that's right. There's only one number and one number only in the range. So that's the nature of this function. Okay, so now for input 0, you have 2. For input 3, you have output 2. For input 10,000, you have output 2. For input -100, you have output 2. What does it make as a picture, as a graph? Okay, how do we make the graph? This is how we make the graph. We put the input together. Okay, we call it ordered pair. Right, you guys have learned that before. It used to be called like X comma Y, right? X comma Y, ordered pair. But ordered pair really in our concept is input comma output. So you put input together as a shorthand notation after this rule is set, and you plot those points. You plot those points, okay? So I'm going to give you a couple of input and you're going to produce the output for me, okay? So now I'm going to have f of 0, f of -2, you give me the output, f of -1, f of 1, f of 3. You give me some output. Can you give me the output for all of these? Of course, we have many more before 0. And we have many more after 3. So according to this rule, can you give me some output? This output will be 2, right? This output will be 2. This output is 2. Output is 2. Output 2. If we do the input output ordered pair, what do we get? Huh? What do we get?
0, 2.
That's right. You're gonna get a bunch of points, right? You're gonna get a bunch of points. Right? So the input is 0, output is 2. The input is -2, the output is 2. So output, okay? The input is -1, the output is 2. The input is 2, the output is 2. The input is 3, the output is 2. Can you guys plot these points for me in a rectangular system? Could you guys plot these points for me in a rectangular system and see for yourself? Do you guys know how to set up a rectangular system? Yes? No? Okay, you draw 2 number lines cross each other, perpendicular to each other. Okay, can you do that? This is x-axis and the other one is y-axis. And you set the scale, you put some tick mark. You put some tick mark. Okay. So now we have input output. So input comma output. So we have 5 points. Okay. So now do you know what to do? You're going to put those points on the graph. Okay, in the rectangular system. Input 0, output 2. Okay, so I'm going to put all these dots and I'm going to mark it for you. And you guys are doing the same, okay? 0, comma 2 is a red dot. And next one is negative 2, 2, negative 1, 2, 2, 2, 3, 2. All these red dots. You guys see that? Red dots. For the input of 0, the output is 2. Input 0 is here. For input is 2, the output is 2. Okay, for example, for this, for input is 3, the output is 2. What is input 3? Input 3, this is how much is 3? And what is the output? The output is this height. So the horizontal measurement from the origin give us the input. The vertical measurement from the origin, the height measured to the, you can imagine this is sea level, the x-axis, and this is 3, and this is 2. So this point indicating 3 is the input, 2 is output. Is it still abstract, you guys? Do you follow me?
Yes.
Input, output, right? So can you mark each one of these points for me on your picture? So this is input 2, output 2. And this one is input 0, output 2. And this one, input is negative 1, output 2. And this leftmost is negative 2, output 2. Every input will correspond to the same output, which is 2. Input, output, input, output, input, output, input, output, input, output. And these are called ordered pair, ordered pair. And for example, for negative 1, 2, right? And what is a negative 1? The output, the input is negative 1. And the output is the vertical. Sorry, I'm going to use the red number. Okay. The vertical is the output. So input is a horizontal measurement from the same point of reference. The output is a vertical measurement from the same point of reference. You follow me? Is it still abstract? Does everybody follow me?
Yes, Professor.
And it's the same thing for you for a long time, for a very, very long time. What's going to be different is the rule. The rule is going to be different. Okay, we're going to see 6 different rules in this section. We're going to see 6 different rules in this section. After you guys write this down, I'm going to show you this principle in use in our daily life. Are you ready? Are you ready?
Yes.
All right, let's go. Okay. I found this S&P 500 index online. Google it. Okay. So right now, so here's a picture. So here's the picture. Actually, this is 1 day picture starting from what time? I think it's 9 o'clock. Okay, starting from 9 o'clock. Okay, do you see the dot? Do you see the dot? Do you guys see the dot?
Yes.
The red dot, right? This red dot, I'm supposed to move it here. 10 o'clock, 10 a.m. What does this dot tell us? It tells us today, 2021 at 10 a.m. the price, I mean the index, it's probably not it's not a dollar sign, it's an index, the S&P 500 index, there's a number there. What is that number? Do you see these two numbers on the top? Do you see these two numbers right here?
Yeah.
3,876.27 at 10 a.m. Okay, it's a reverse order from from what we do here, right? Okay, because the horizontal is but this is for reading convenience, but it's still a pair of number, right? It's just in different order, right? So at 10 a.m., that's the index. And we keep going at 10 minutes past 10. And now let's see at 11. Do you see the number at 11? Is that a pair of number? Yes? Is that a pair of number? Do you guys see that? 3,895.36 at 10:55, at 11, at 12. Are we there yet? No, we're not 12 yet. So what this number is all about? March 1st. Oh, we're 3 hours behind. So this is Eastern Standard Time. You follow me? So at 9 o'clock Pacific time, that's the index. You follow me? And this is mathematics in application. The only difference between this function, this is a function, because for each input, the input is time, the output is the index, right? You follow me? For each input, there's a unique output. Do you see that? At each moment, there's a unique price, but there's a unique index. Do you follow me? Does everybody follow me? Right now it's 2 o'clock, I mean 2:09 Eastern Standard Time. So we don't know what's going to happen at 3 because we only live up to this moment. The only thing that in this case, in stock market case, is that we never know what's going to happen next. You guys understand that, right? So this is a function. This curve is a function. Why? Because it satisfies the rule of a function. For each input, which time is the input, there's exactly one output. You guys follow me?
Yes.
So is math still abstract to you now? Is it still abstract? Do you have any interest about any particular stock? For example, since we're here, we can play a little bit.
Try GameStop, Professor.
GameStop, why not? GameStop. Share price. Oh, it goes up. Right here. GameStop was in the news, right? It was really, and you see it started today at $104.54, and there's a dip at 950, and then it goes up. You see that? Every moment there's only one price, isn't it? Do you follow me? Every moment there's only one price. That's exactly one output. Do you follow me? So the input is time, the output is the price of the stock. So for at each moment, there's just one price. And you can track that momentarily until this moment. The only thing we will not know is what's going to happen in the next moment. So we don't know that function. So we know the function only up to this moment. We don't know what's going to happen next. And that's the most frustrating thing for human, because we never be able to know what's going to happen in the future, right? And that's why there's all these betting, all these speculation, and all these guesses, educated guess, uneducated guess, all kinds of guesses, or all these risk has been taken. There are people out there taking risk because some people may anticipate, oh, in the next moment it's going to go very high up. So I'm going to buy at this moment, therefore next moment I'm going to make a lot of money. Or some people say, oh no, next moment it's going to come down. I'm going to be selling right now so I can avoid that loss. Do you guys follow me? All kinds of human psyches start to play out. So that's the most bewildering things about stock market, because we never know what's going to happen. We only know what has happened up to this moment. Isn't that interesting? I mean, I personally don't really understand stock market myself. Okay, I never actually traded. But just look at the curve. I can tell you this curve is a function. That's the point of my using this curve in class. Okay, it is a function. And the other point I want to make is a function as very you may think it's abstract concept. It may be, but now it is for real. The real world use this function, use the concept of function all the time. All the time. You follow me? Even your cell phone is full of functions, isn't it? Your cell phone is full of functions. So now is function still a very abstract concept now? Probably not anymore, right? Do you follow me? Do you follow me?
Yes.
Yes.
Okay, so do you agree this is a function?
Yeah.
Yeah. As long as for every moment there's exactly one output, it is a function. So the input is time, the output is the price. And where do you see the price? The price is marked vertically. You see, vertically. So you want to know the price, you just have to know how high is this broken line. Measured from the same level. You guys see that? And the time is all measured from the year from the year when Jesus was born. That's how time is measured. That's how time is measured. Okay, of course, this is just a part of it. This is just a little part of it. Because I think the trading started at 9, isn't it? Is the trading start at 9 Eastern Standard Time? Okay. Now, we know function now, right? We know function now. Let's come back to our simple function now. Okay, this is a constant function. What if we connect the dots? What will happen? What if we connect the dots? It's a horizontal line. If the star, if a particular star could show this picture, what does that mean? At every moment, the price is the same. There's no ups and no downs. But if you are in, I hate to use this example, okay? Suppose one day I died. You know, one day I will die, right? What will the machine show about my heartbeat?
A dead straight line.
It's a dead straight line. It's this line. It's a line like this, dead. There's no up and downs. My heart is no longer pumping. Does that make sense? From that point on, right, every moment, the curve is the same state. 0. No life. Do you guys understand what I'm saying? That's what constant function means. Constant function means that no matter what's the input, the output is always the same. You follow me? Domain and range. So with that understanding, okay, we have the domain, we have the range. So let's look at the second function on the table. The second function, what is the second function? You guys have it there? Do you guys follow me? The second function is f of x equals to x. Well, if you call it y, okay, you probably have learned this before, right? In your previous experience, you probably have seen this before. Have you seen this before in elementary algebra? I bet you did, right? Okay, so now I insert this function notation. What does this function mean? What is the rule? What is the rule? What is the rule? This rule says, whatever input you give me, I'm going to push it out and produce this output. The output is exactly the same as input. That's the function. Do you follow me? So if you look at it from the function's perspective, okay, you go through this function. Okay, this rule says, whatever the input you give me, the output is going to be the same. The output is always the same as input, no matter what input you give me. That's what it means. The output is always the same as the input. That's what it means. You guys get it? Yes? So from the input-output perspective, according to this rule, okay, what if your input is 0? What will be the output? It's going to be 0. If the input is 0, the output is 0. If the input is 0, the output is 0. You follow me? What if the input is 1? According to this rule, what will be the output? I want you guys to give me some numbers, okay? Are you guys there? What will be the output? For these. Hello? What is the output for input 1?
1.
1. Excellent. What is the output for input -2?
Negative.
Huh?
-2.
Perfect. What is the output for -1?
-1,
Wonderful. What's the output for 1?
1,
What the output for 2? Input
2.
2. Perfect. You got it. Okay. Each input given, the output produced will be exactly the same as the input. That's what this rule says. As a result, what are the points we get? Input, output. So that'll be 1, 1, right? -2, this -2, -2. -1. Can you make those points? Do you get those points? In your previous experience, you probably make the tables, right? You probably make the tables. So what's the input here? The input is 1, the output is 1. Input is 2, output is 2. Can you plot those points? Can you plot those points? Could you guys plot those points? You guys know what to do? Get a piece of paper and plot points. And we're going to plot those points. Red dots. And you mark every point. Okay, let me show you how you mark it. You mark each point. Input, output. Imagine your GameStop stock goes along this line. How would you like it? And do we connect the dots? What happens if we connect the dots? It goes up. It goes up. Follow me? So that's the second one. How about domain? What's the domain? What's the range? What is the domain? And what is the range? What's the domain and what's the range? What's the domain? What's the range?
All possible number.
All real numbers. Perfect. All real numbers. Okay, I see the answer on chat. Okay, great job. All real numbers. Okay, and the range is the same because the consequence of operating on all the real numbers, the output is always the same as input, of course, right? All real numbers. Two more questions to answer. X-intercept, Y-intercept for both functions, okay? For the last function, we didn't talk about X-intercept, Y-intercept, so we're gonna go back there to wrap it up. And after we're done with X-intercept, Y-intercept, and we're gonna take a break and we'll come back to work on the other functions, okay? So now, what is X-intercept? What is Y-intercept?
0.
By the way, before we move on, when I ask you to graph, you must mark the points. You guys follow me? I will tell you how many points you need to mark, but you need to mark the points like this. Do you follow me? Yes?
Yes.
If you have a graph without marked points, you're gonna lose a lot of points. Because I have those marking points thing as a part of the, you know, as a part of reasons to give points. Okay, I will tell you how many points is expected to be marked, but you must mark some points. Okay, how do you mark it? Input, comma, output in parentheses. Okay, all right. So intercept. Have you guys heard of X-intercept, Y-intercept? X-intercept is where the curve crosses x-axis. Y-intercept is where the curve crosses y-axis. This line crosses the origin. So X-intercept and Y-intercept overlap in this case. Okay, so the Y-intercept here is also 0, 0. Okay, so there's not much of suspense here. Okay, X-intercept is 0, 0, Y-intercept is 0, 0. Okay, they cross this point, it crosses both X-intercept, X-axis and Y-axis. So after you write it down, we're gonna go back to our previous question and we're gonna answer that question. What is X-intercept? What's the Y-intercept? Okay. Are you ready? Okay, so I'm gonna erase everything. Okay. So I'm going to put it here. domain and range. Okay, X-intercept. Is 0, 0. And Y-intercept is the same. Now let's go back to the constant function. What is X-intercept and Y-intercept? You know, in this second case, the intercept, the Y-intercept are the X-intercept and Y-intercept the same. How about this one? What is the X-intercept? Does the line cross X-axis?
No.
Nope. So there's none. Okay. Does the line cross the y-axis?
Yes.
Yes. What is it?
2.
What is the y-intercept?
2.
Incomplete answer. You need to give me a ordered pair.
0, 2.
That's right. 0, 2. Okay. You need to indicate what's the input and what's the output.
You could also say y equals 2, right?
No. You just give me this answer for intercept. I don't take any other form of answer. Okay. Because when you say y is 2, you need to tell me what x. 1 is y equals to 2. So this 0, 2 tell the reader that when input is 0, y is 2. If you only tell me y is 2, that's incomplete. Do you follow me?
Yeah.
I'm not saying you're incorrect, it's just incomplete. Okay? Did I make myself clear?
Yeah.
When I ask for intercepts, you need to give the input and output as a pair, or x, y as a pair. Is that clear? So that'd be for the entire semester, Okay? Now, we're gonna move forward a little bit more and then we take a break. Okay, let's look at number 3. Number 3 is a category of functions you probably have learned before, haven't you? Number 3. Who has never seen mx plus b? This is a category of functions, right? M is the slope, b is the y-intercept. Okay, the y-coordinate or y-intercept. Now, I'm going to give you an example. Okay, this function, suppose I give you 2x plus 1. Now we do it from the function perspective. Okay, do it from function perspective. Let's look at the rule. The rule says I have an input. This input is given. And the rule applies to it. It produces an output. And this output is f of x, of course, equals 2x equals 1. How does this rule work? You give me an input, right? I take this input, I multiply the input by 2, and then I plus 1. I operate on your input x, and an output is produced. Do you follow me? If this is the rule, I'm going to ask you to produce some input, produce some output for me. Could you produce some output for me? Could you produce some output for me there? So for input -2, what is the output? You just plug in, right? So this is going to be -2. The output is -3. So when input is -2, the output is what? So in that input output scenarios we're working with, right? We're getting these points. So when the input is 0, what do we get for the output? So input is -2, the output is -3. Input is -2, output is -3. Input is 0, output 1. Input 1, output is what? 3. Is that what you got? Hello?
Yes.
Is that too easy? It shouldn't be too hard for you, I hope. And now can you plot the dots and connect the dots? And also answer these questions. Domain, range, intercept. X-intercept, Y-intercept. What is the domain? What is the range? And what is the graph? Right? What is the graph? I'm going to plot the points. Input a -2, output a -3. Red dot. Input 0, output 1. One more, input 1, output 3. Okay. And we connect the dots. Did you connect the dots? Right? Does this look familiar to us? You've done this before, haven't you? Yeah? Now, intercept. What is the X-intercept? What is the Y-intercept? What's the domain? What's the range? You probably have, I'm sure you've learned this in elementary algebra, right? Now we look at it from different perspective, from a function perspective. Input output. What's the domain? Domain is all real numbers, right? From -infinity to +infinity. You can use these notations. And the range is also from -infinity to +infinity. And the Y-intercept is 0, 1. And the X-intercept, what is X-intercept? What is X-intercept? How do we find X-intercept? We know there's a point there, right? We know there's a point there. How do we find it? How do we find it? How do we find X-intercept? How do we find X-intercept? To find the X-intercept, we need to set what? We need to set the output equals 0. You guys learned before, right? You set y equals 0, right? You set the output equals 0. You set output equals 0. What do we get? When input is x, output is 2x plus 1. So the output is set to equal to 0. And we solve for x, right? If 2x plus 1 equals 0, x will equals to -½ So the X-intercept will be what? So X-intercept as a result will be an ordered pair, -½ is the X coordinate and the Y coordinate is 0. -½ is the input. We try to find input from output. That's the X-intercept. Any questions so far? Okay, I believe this part is review, but if you have any questions, so please don't hesitate. Okay, if you have any questions, so please hesitate. Please don't hesitate. Okay, I'm just going to mark these points and we're going to take a break. Okay, so hopefully you see the complete answer here. And over here, that's the 1,3. And the X-intercept here, I'm going to mark it here, this point. Okay, this X-intercept point is going to be -½ comma 0. Okay, and this other one, 0,1, that's the Y-intercept. Is that clear, everybody? Is everybody with me?
Yes.
Very good. Let's take a break. Let's take a break. We come back at 11:55. Okay, right now it's almost 11:45, so we'll come back at 11:55. Okay, back at 11:55. I will see you guys later. Okay, I'm going to pause this. It's actually, you know, it makes sense, right? We see some mathematical, more abstract form, and we actually see how it works, right? And how we make the graph. And the way we make the graph is very typical of, you know, a function. You can see it's being used on stock market, right? Even though we cannot predict the future, but we can plot all the points we know every moment, the change of price and so on and so forth. And mathematically, we just go a little bit more abstract, right? We just go a little more abstract. Okay, but it's all about numbers. And next, we're gonna get to number 4. Are we ready? Number 4. Number 4. What is number 4? Okay, clear all. So let's look at number 4. Number 4. Another function. I'm gonna make 150%. I just make it a little bit larger. Okay, this function Let's see what kind of rule is this. Take a square root. Take a square root. Okay, so we have an input. The input is given to the function, given to this rule, right? It produces an output. And what is the output? The output is just f of x equals radical x. Okay, radical x. So let's try some input out. Let's try some input output. Okay. So suppose that the input is, I'm gonna give you some input. Okay. I'm gonna give you 0. I'm gonna give you 1, 4, 9, 16. Should I give you some negative number as the input? Can you give me the answers? Could you guys give me the answers? Could you give me the answer? Come on, guys. Come on. What is the root of 0?
0.
0. Very good. What's the root of 1?
1.
1. And what's the root of 4?
2,
Root of 9?
3,
3.
Perfect. I'm sorry, I made a typo here.
That's 4.
4. Wonderful. How about root of -1?
Is it -1? No. What is the root of -1?
Well, the root of -1 is actually a very interesting phenomenon. Okay. If
Did
we
you say I?
You're right, it's I. However, in this course, we don't deal with I because I is a complex number. Complex number does not plot in the rectangular system as we know. Okay, so for now, we will say it is undefined in real number. You follow me? So we don't deal with it. So we only consider the output is real number. So the exactly one output has to be real number. Do you follow me? And therefore, the domain for this function, okay, I'm glad you guys know I, right? The domain for real numbers for this function is x at least 0. We don't consider taking root of a negative number at this moment. Okay, in future, in this course, we might deal with I, but we're not doing the graphing. We're not doing the graphing. So for now, in terms of graphing, we don't deal with I at all. We don't deal with I at all. Do you follow me? And what is the range? The range is greater than or equal to 0 as well. Okay, for those of you who have learned the interval notation, right? The interval notation, that'll be 0 in bracket and infinity. And the range is the same. Okay, so I'm going to put it as or. Okay, or. You follow me? Now, we have two forms, interval or inequality, to express domain. Which one is preferred? I assume that everybody knows the interval, so I'm not going to test you on that. I'm going to only test you on the inequalities. So this is the form that will get you the point. These are not wrong. They're correct. They're not going to get you points. You follow me? They may get you points sometimes, actually. I wouldn't say absolutely not. Okay, they may get you because we have multiple choices sometime on the quizzes. So you get to, you can use it. You can still get points, but you know that they're like something I already know you guys know, so I'm not going to test it, that sort of thing. Okay, so let's plot some points. Let's plot some points. So in terms of the input output, so what I have shown you is you can see that we handle different rules pretty much the same way, don't we? We study the input, we study the output, we study domain, we study the range, and we make the input output pairs, and we plot the points. So we use the same method to study different rules. Do you follow me? Do you guys follow me? We use the same methods to study different rules. So different function, different rules. Do you follow me? So do you see that consistency? Do you guys see that consistency? Are you sleeping? No answer. You say something. So in terms of input output, can you get these points for me? Can you make these points and plot these points? And then you're going to tell me what are the X-intercepts, what are the Y-intercept? Yes? No? Yes? No? You guys are working on it? So when input is 0, output is 0. Input is 1, output is 1. Input is 4, output is 2. I didn't choose any decimal numbers or fractions. Could I? Could I choose those numbers? Of course I can, but I'm just being lazy, right? I'm just being lazy. I'm just going to choose some numbers that are easy to calculate. And then you're going to plot the points. And then you're going to study what is the X-intercept. And what are the Y-intercept? Are you guys doing that? Now we're plotting the points. Dot. 1, 4, 2, 9, 3. Last but not least, 16, 4. Need to make adjustment to there. Right? Is that what you got? Now what happens if we connect the dots? And we mark the points. Okay, always mark your point. Right? So that's the graph. And what are the x-intercept, y-intercept? X-intercept, y-intercept, you guys? So under this rule, we get this picture. We get this picture, right? Under this rule, we get the picture. How come nobody says anything? What is the x-intercept? What is the y-intercept?
Both of them are 0, 0.
Perfect answer. Okay, so far we got pretty easy functions, right? So we have 2 more to go. 2 more to go. Okay. Domain and range, we got it. Range, right? So let's look at number 5. Look at number 5. Okay, did you write it down? You must mark the points. Okay, you must mark the points. All right, too easy. All right, number 5. This function probably is very familiar to us. Okay, this function probably very familiar to us. And of course, we're going to use the function notation. Okay, so what kind of rule is this? Input. And what is how does the output work? The output take, the rule takes the input and multiply itself, right? X is input and x squared is x times x. And it produces the output, and output is x squared. Okay, so we're gonna do the same thing, right? You can see we use the same method. The same method applied to every rule of function, every rule of function. So next, I'm going to give you some numbers to plot. Okay, I want every one of you does this because, when you do this, okay, when you do this, you are going to have that hands-on experience. That hands-on experience is absolutely valuable to you. Okay, so f of 0. Okay, so you're going to plug in. Be sure you put a parentheses here. Okay, you put a parentheses here. If you miss the parentheses, you're making a mistake. Okay, so note. Okay, with parentheses. And without parentheses. These two are different. Okay, the former equals to -2 times -2. The latter is equals to -2 times 2. So they are different. Okay, so f of, I'm just gonna give you 2 more input. Oh, sorry. 2 more. One is 1, one is 2. Okay, so you are going to make the points. You're going to compose the points. You can see we consistently using the same methods of study. For different rules. And then you connect the dots. Make the points. And we connect the dots. Are you guys there? So when this is -2, the output is, what is the output for -2 as input? What is the output for -2?
-4.
-4?
Yeah.
+4.
Oh wait, it's +4. It's positive, sorry.
That's right, +4 is -2 times -2. Very good, okay. The best correction is self-correction. Okay, so when input is -1, what is the output?
+1.
+1, excellent. The input is 0, what is the output?
0.
Input is 1, the output 1. Input is 2, output is, okay, so shall we plot them? Could you plot them for me? Okay, on your paper. We're gonna plot the dots. Input, output. You can see the method of studying is really consistent, isn't it? You see consistency. Yes,
Yes.
consistency. Some people already, accusing mathematicians for, you guys have no creativity. Okay, you do the same thing over and over again. I take that. I'm not a terribly creative person. Okay, but mathematics study is a systematic, consistent process. It's a systematic, consistent process. Okay, everything later is consistent with what's been done before. There will never be any contradiction to what's been done before. Before, I mean, in the past thousands of years of mathematical studies. Everything we do today will be consistent with what's been done before. If they've been done before. Okay, anything new will not be in contradiction with anything that has been done before. Okay, I mean before is the past thousands of years of human achievement in the field of mathematics. Okay, so now let's connect the dots. Boom. Okay, so you can think of domain, range, x-intercept, y-intercept. So what is the domain? Let me put it on top. Okay, let me just put it on top, or maybe in the bottom. Top. Domain, range. Okay. Intercept, x-intercept, y-intercept. We may not be, terribly creative, but only after you know mathematics some more, you will start to realize there are some creative ideas in mathematics. They are, okay? And for example, these systematic ways of processing mathematics, processing numbers. The first time it was someone created it. Okay, and it's been adopted as systematic way, consistent way to study. Okay, all right, so what's the domain and what's the range? And let's mark the points. Okay. And so what's the domain? What is the domain? What is the domain?
Y is greater than 0, greater than or equal to 0.
Y is about input. Domain is about input. What are the numbers? What are a collection of numbers that this rule can apply? And for every such number, you produce exactly one output. Right? This rule is about what? You give me an input, I'm going to multiply, I'm take the input and multiply itself, and then produces the output. Right? For this kind of process, what are all the possible numbers that are fitting to apply this rule to? Would that be all real numbers? Would that be all real numbers? Because any number, positive, negative, 0, you can use it as an input, right? And that input going through this rule, follows this rule, time itself is going to produce exactly one output, isn't it? You follow me? The consequence, however, the output for the range is greater than or equal to 0. If that's what you meant.
Oh yeah, sorry, I got them mixed up.
That's right. Domain and range are two different things. What you said will be for range and not for domain. Okay. And in fact, domain and range in one, sometimes we can, enhance our understanding to describe domain and range in one sentence, right? So we will say x squared is greater than or equal to 0 for any real number x. That's domain range in one sentence. Very useful stuff. This is very useful stuff. I want you guys to write it down and, and mark it as the important item on your list. Okay, so whatever symbol you use for important items, okay, make sure you understand it. Because any number times, any real number time itself is going to be at least 0, greater than or equal to 0. So now let's look at intercept. What are the x-intercept, y-intercept? Do we have any? Does the curve cross x-axis? Does the curve cross y-axis?
0,
0, 0.
Perfect. Okay, very good. Okay, very good. Wonderful, wonderful. Okay, last one, last function on the table. Okay, last function on the table. All right, this function certainly is a very interesting function, very useful function, and but yet there are many places it can be very difficult. Okay, I was working with my pre-calculus class students. They have some trouble with, what we are about to work on right now. Okay, y is equals to f of x. It equals to absolute value of x. Do you guys understand what is absolute value? Do you understand what is absolute value? Do we understand what is absolute value? Okay, no? The absolute value, okay, of a number is the distance between that number to origin. Okay? On a number line, the absolute value of a number is the distance between the number and origin. What does it mean? Suppose I have a number line. This is the number line, okay? And this point is the origin, okay? And I have some tick marks, okay? So -1, -2, -3. +1, +2, +3. And so on and so forth. Okay, so I'm gonna mark it. So here's -3, and here's -2, and here's a -1, and over here it's 1, it's 2, it's 3. Right here, 3. Distance. Suppose I look at the numbers -3. Okay. The absolute value of -3, the absolute value of negative 3?
3.
Absolute value of negative 3. And I use a special notation to represent this phrase, okay? It's marked as the absolute value of negative 3, so that the word that, the words, the absolute value of negative 3 is equal sign, is the distance between the number and the origin. So what I do is that I know this is negative 3 and this is my origin. I just need to know how far they are apart. I don't care the direction, okay? So from negative 3 to 0, it measures 3 units, 1, 2, 3, 3. So it's going to be positive 3. Do you follow me? Do you follow me?
Yes.
Yes, Professor.
Okay, so next, how do I describe the distance, the absolute value of 2? What is the absolute value of 2?
2.
It is the distance between, it's the distance between 2 and the origin. So they have the same reference point to measure from. And we don't care about which direction. We just want to know how far apart, right? It's like you go to grandma's house. You just know the distance. You just know the distance. You just, get on your, GPS, or supposedly, I'm sure you already know where she lives. And you don't really need the GPS, but it's the absolute distance, okay? So the absolute value of 2, we use a shorthand notation, and this shorthand notation is such. The absolute value of 2, meaning is the distance between 0 and 2, of course, this is 2. Now, next, what is the absolute value of 0? What is the absolute value of 0? The absolute value of 0 is, you still measured from the origin to 0. So you basically stay the same spot, right? The absolute value of 0 is 0. Does that make sense?
Yes.
Okay. This is the concept of absolute value. Well, of course, you can use decimal numbers. It's negative 3.5, and this is going to be 3.5. Okay, you're going to measure, okay, how far apart from negative 3.5 to 0? Oh, that's going to be 3.5. Does that make sense, you guys? Okay. So how does this function work, right? Because we're talking about function, right? We're talking about function. So now I'm going to clean all of this up. Okay, and we look at this as a rule, as a function. You know how this works, right? You know how this works now. So this rule, how does this rule works? This rule, of course, still takes the input. The input is given to this rule. The rule look at this. The rule look at this input and process it and produces output, just like any other function. It's just a different rule. Just a different rule. Now the question is, once again, domain, range, X-intercept, Y-intercept, input, output pairs, and you graph the points. Do you follow me? Well, we have some nuances here. So now, tell me, if this is a rule, to how many numbers can this rule apply to? What are they? So what is domain and what is the range?
The domain is all real numbers.
Perfect. Very good answer. Okay, because you can apply this rule to any number. It's going to produce exactly one output, right? So it's fitting to the definitional function. And what is the range? What is the consequence after applying these rules to all those numbers? What do you expect? Consequence. What will be the range?
X is greater than or equal to 0.
Perfect. Wonderful. Does everybody agree?
Yes.
So you have this rule, you apply the rule, right? You figure out all the possible numbers we can apply the rule to, and then we know the consequence, right? So let's look at the points and also figure out the intercepts, right? X-intercept. I think some of you probably is already working ahead of me. Feel free, go for it, okay? Y-intercept. Okay, so I'm gonna have you, evaluate some numbers. F of -2, right? F of -1. F of 0. F of 1. And F of 2. You give me those values. So just plug in the numbers, apply the rule. Pretty straightforward, right? Pretty straightforward. Okay, so you're learning a new notation. If you've never seen this before, but I believe you've seen it before, right? So what's the absolute value of -2?
2.
2. And what's the absolute value of -1?
1.
Perfect. Absolute value of 0?
0.
Perfect. Absolute value of 1? Absolute value of 2? Right? And then we do the same thing again. Do you guys see the consistency? I just hope you guys don't get bored. Okay, it can be. But there's a lot of certainties as how we handle them, handle the rules, right? There's a lot of certainty that as how we handle the rules. It's not that, oh, today we use this method, tomorrow I'm going to change it totally to a different method. No, we use the same method of study. We all have interpretations and we have applications. Okay. And so when input is -2, the output is 2. Input is -1. I bet you some of you probably started plotting the points and go for it. Okay, so we get these points. We're getting, 5 points. Okay. And along the way, have you recognized what's intercept, what X-intercept, Y-intercept? I think some of you probably already recognize it, right? So along the way, we get some stuff. We use a consistent method to study this. Really, okay? There's no surprises. Just we have to be clear about the rule. We just have to be clear about the rule. Okay. Now we're plotting the points. 5 points to plot. We'll just patiently plot them. Right? And then we connect the dots. We connected the dots. There we go. That's the graph. Input, output, you know, that we handle the same way and we plot the points, right? So we mark all of these points. So over here is -2 input, 2 is the output. Over here, that's going to be -1, 1. And input is 0. Output is 0. And input is 1. Output is 1. Input is 2. Output is 2. Boom, we got it. Okay. Intercept. What are the X-intercept, Y-intercepts? Hmm?
Zero, zero.
That's right. They're the same. X-intercept, Y-intercept are the same. 0, 0. Okay. So by this time, we're kind of done with these functions. But for alpha 5, or for let's see, we did alpha. We did number 6. We did number 6. We did all of it. Okay, there's one more item we did not discuss yet, which is one-to-one function, Okay. Since we are addressing these function concept, I would like to introduce one-to-one function definition. Okay. We have 20 minutes to go. I hope you guys are not too tired. Are you guys tired? Okay, get something to drink. Okay, we have 20 minutes to go. Now, one-to-one function. One-to-one function. What is a one-to-one function? We have a definition there. We have a definition here. Okay, and here how the definition states. Okay, so I'm going to copy and paste and put the definition here. I want everybody to write it down and carefully think of its implication. Carefully think of its implication. Okay, carefully think of its implication. What is the implication of this definition? This definition is definitively very, very important. What is a one-to-one function? What does it say? Okay, so here, it uses some words we may not have heard before. Okay, or at least used in mathematics. A function with a domain A, okay, is called a one-to-one function if no 2 elements of A have the same image. The same image will actually mean the output. Okay, image means output. Okay, sometimes the output is called image. Okay, so we're going to use the word output. All right, we understand A is a domain. A is a domain, right? So what does this mean? Basically, say that is, it says, whenever the input are different, okay, whenever the input are different, while one input is not the same as the other, and their output will not be the same as well. Okay, so whenever the input is, whenever the any two inputs, if the inputs are different, the output are different as well. Okay, so we're going to use this criteria to check 1, 2, 3, 4, 5, 6 functions we just studied. So we're going to decide which one is one-to-one and which one is not one-to-one. You follow me? Do you follow me?
Yes.
Okay, so let's look at the first one. F of x equals to a constant. We use a 2. Is this function one-to-one? Okay, so we're going to apply repeat PLY this definition to determine which of the 6 functions are one-to-one, is our one-to-one. So is this function one-to-one? Well, you have to look, first you have to look at the domain, right? So the domain of this function, what is the domain for this function? It's all real numbers, isn't it? Is it true that for any 2 different input, we get different output? Is it true or not? That's not true, isn't it? Because for every input, you're going to produce the same output. And there are infinite numbers in the domain. Therefore, you can always find 2 different input, but they have the same output. So violates the definition of what? Of one-to-one function, right? Do you follow me? Do you hear the logic? Do you hear the logic? Yes or no?
Yes.
This function, okay, this function is not one-to-one as for, say, for input x1 equals to 1, x2 equals to 3, for example, right? Their output will be the same, right? Even though x1 is not the same as x2, but their output are the same, right? So you have a pair of different inputs, but their output are the same. Okay, so f of x1 is the same as f of x2. Which is both equals to 2. Therefore, it violates, right? Therefore it's not one-to-one. So if you read the definition of one-to-one, is whenever input are different, the output must not be the same. And here we have different input, but we have the same output. Therefore, it is not one-to-one. Do you guys follow me? So that's contrary to the requirement of one-to-one function. Yes, are you following? Do you follow me? Are you tired? I'm sure you are. I'm sure you are. Okay, 12 more minutes. So let's look at the next function. F of x equals to x. Is this function one-to-one? Output is always the same as input, right? Output is always the same as input. Is this one-to-one? Does it agree with the definition of one-to-one function? This is the definition of one-to-one function. It is a function. Surely we know it's a function. Is it one-to-one? Well, the output is always the same as the input. So when the input are different, the output are different too, right? Yes. So how do we reply this? How do we answer this? Then you'll say, yes, it is a one-to-one function. As for, or as, okay, we can quote this here. Whenever the inputs are different and their output are different as well. Because the input, the output will be the same as their respective output, right? Okay. How about number 3? Number 3 is a class of function. Okay. So we're not going to, we are going to study this, but I'm going to just give you the answer. So because if the slope is not 0, this is a one-to-one function. So provided that the slope is not 0, why slope cannot be 0 in order to make it a one-to-one function? Because if the slope is 0, it's going to be a constant function. Do you follow me? If the slope is 0, it's going to be a constant function. So if this is the case, if the slope is not 0, yes, it is a one-to-one function. So I'm going to put the answer here. And I want you to think about it. If you have any questions, come back to me. Okay. Number 4. Number 4, what kind of function is this? It's a square root function. The domain is with all non-negative numbers greater, x is greater than equal to 0. The range is greater than equal to 0. Is a one-to-one function? And yes, it is a one-to-one function as well, because if any 2 input are different, you take square root, they're still not the same, right? So it is a one-to-one function as well. Now look at number 5. This time the function is x squared. Is x squared a one-to-one function? I'm going to wrap this up, okay? And the answer is, it is not. Okay, why? Why? Because, no, it is not a one-to-one function. For example, okay, for x1 equals to 1, x sub 2 equals to -1, surely x1 is not equal to x2. but we square them, right? But f of x1 is equals to f of 2, because when you square 1, you get 1. When you square 2, when you square negative 1, you also get 1. You follow me? So this is not. Last but not least, the absolute value function. I'm going a little fast here because I want to wrap this up. If you have any question, and of course you're gonna have a quiz about this, okay? About this entire what we did today, and for the same reason, okay? So number 5, number 6, they're not a one-to-one function. Why? Because you have a different input. You have at least one pair of such. You only need one counter example. You have a pair of input that are different, but their output are the same. So that concludes this section of one-to-one function. Okay, so we have covered 6 functions, right? 1, 2, 3, 4, 5. So these 6 functions are very, very important. They are the simplest form in their categories. And we know the functions are rules, and we naturally consider their domain and range, X-intercept, Y-intercept. And what is more, we determined some of them are one-to-one functions, some of them are not one-to-one functions. Well, we have criteria for it. Okay, but these 6 functions will be intensively studied, and some of these are going to be, we're going to spend a lot of time. For example, x squared. Okay, we're going to study the x squared form in variety of situation, which is leading us to quadratic. That's looking forward. Okay. And do you guys have any questions? Yes, no?
No, Professor.
Okay, it's we will continue this tomorrow on Wednesday. On Wednesday, we're going to do alpha 5. Actually, alpha 5, we're going to continue study the absolute value. Okay, there will be some interesting facts and but difficult stuff for us to learn. But that's all for today. Let's see, I got one message here, no question. Okay, Marcelo, but when you have questions, you know where to find me, right? You should have Pronto, you have Inbox, you have Canvas, you have emails. And last weekend, we didn't have any question. How did you do on the quiz? On the written one, you have a 1 multiple choices one, you have a 1 written quiz. How do you think you do? I will start grading them very soon. Okay, as soon as I finish grading, you're going to see the score. Okay, so I will see you guys on Wednesday. If you have any questions, please don't hesitate to reach out to me anytime. And have a great day. It's very beautiful outside, and the sun is shiny and bright. Have a very nice day. I will stay a few minutes longer. If you have any questions, please don't hesitate to ask me.
Thank you, Professor.